Hello and welcome everyone. In this new session of GD&T, Geometric Dimensioning and Tolerancing, we are going to learn about the rule 2. Okay. In the previous discussion, I have already told you about the rule 1, how you have to override rule 1, what are the requirements of rule 1, how we have to verify the rule 1. Okay. So in the rule 2, this is a default condition. Actually, rule 2 is a default condition. And in this particular session, we will understand, okay, about rule 2. So rule 2 basically says that regardless of feature of size, okay, so regardless of feature of size or RFS, okay, is a default condition on of all geometric tolerances by rule 2 of geometric dimensioning and tolerancing and requires no call out. Okay, so in this is a feature control frame. This is a feature control frame. And in this, you can see this is the geometric tolerance value. So this is the geometric tolerance over here. Okay. And this has in this, if there is no modifier is used, means this is regardless of feature of size. Previously, we used the symbol, but from the 2009 standard, there is no requirement of using the RFS symbol. Okay. So this is a default condition. So rule 2 basically says that RFS regardless of feature of size is a default condition of all geometric tolerances by rule 2, and geometric dimensioning and tolerancing requires no call out. Okay, so regardless of feature of size simply means that whatever GD&T call out you make is controlled independently of the size dimension of the part. Okay, it is controlled independently of the size dimension of the part. RFS basically, if in simple terms we understand, here is in the geometric dimensional geometric tolerance where there is no modifier symbol is used. Okay, so you can see that in this there is no modifier symbol we have used in a default condition. Okay, which is a default condition we have already discussed. And here we have three datum references: primary datum, secondary datum, and tertiary datum. Okay, so we don't have any modifier symbol in the references also. So here also we haven't used any symbol. So this is also a default condition. If we are not using the modifier symbol in the geometric tolerance column in this compartment, so in the datum compartment also we are not using the modifier symbol. Okay, so where there are no modifier symbol in either a tolerance segment or a feature control frame or of a datum segment. Okay, so these are the datums of feature control frame, then it is called the regardless of feature of size. Okay, and regardless of feature of boundary. Okay, so this is called regardless of feature of size, and in this it is called regardless of material boundary. Okay, RFS and RMB, and this is a default condition. This is a default condition. Okay, now here we have an example. So when a geometric tolerance is applied on an RFS basis. Okay, so here you can see this is a feature control frame, and in this feature control frame the geometric tolerance is applied on an RFS basis. Okay, so there is no modifier we have used. The geometric tolerance is limited to a specified value regardless of the size of the feature of size. Okay, so geometric tolerance value is limited to the specified value. What does this means? Let's say this diameter of this is 50 plus minus 1 over here. Okay, so 50 plus minus 1 means what will be the maximum material condition of this hole? Will be 49. Okay, and least material condition of the hole is dia 51. Okay, so for this hole, whatever the size dimension, whether it's a MMC or LMC, the tolerance will be 0.2 only. Okay, so 0.2 will be the geometric tolerance for either 0.2 for this, and even if the part is produced at dia 50 also, then also the geometric tolerance value 0.2 will be there. Okay, so whenever the feature of size and the positional tolerance for the positional tolerance, there is no modifier is used. For the datum, there is no modifier. So this is a default condition where the regardless of feature of sizes applies. Okay, so whenever we have RFS, then we have a tighter tolerance. Okay, whenever there is a default condition, we have RFS, there is a tighter tolerances. Okay, in this case, hole can be produced. I have already told you that hole can be produced whether at 49 MMC or 51 at LMC, but the positional tolerance remains same. for both the cases, which is 0.2 only. Okay, it remains constant. In most of the general applications like jig and fixtures, gauges, machine tools, okay, so machinery, we require tighter tolerances. In that case, we use such cases, we go with the RFS regardless of feature of size. Okay, where there is tighter tolerances is required to in the manufacturing, we go with the RFS. Okay, and RFS is a default condition by the rule 2. Now we will understand that whenever it is necessary, okay, so whenever it is necessary, we can use MMC, maximum material condition, or LMC modifier may be applied. Okay, in that geometric tolerance value over here, you can see this. In this condition, we can use MMC modifier, maximum material condition, in the feature control frame after the geometric tolerance value. Okay, and we can apply the applied to a feature of size and which is maximum material boundary. Okay, so both symbol are this is after the datum, primary datum. So in this MMB or LMB modifier is also may be applied for the datum reference of the feature control frame. Okay, so this is we are coming out of the default condition. But if there is requirement of applying MMC or LMC, so we can apply into the feature control frame. So here we have the example of the maximum material condition applied to a tolerance. Okay, tolerance, and maximum material boundary applied to a datum reference. Okay, here we have similarly we have the least material condition applied to a tolerance and least material boundary applied to a datum reference. Okay, so this is very important. We take one of the example of maximum material condition. Okay, so when so here we have some flexibility whenever we are using maximum material condition modifier. This modifier, we got some flexibility in manufacturing. Okay, this flexibility, how we get, I will be telling you this, that we get the flexibility after applying the maximum material condition. Let's say okay, so when the hole is produced at MMC, in this case, if the hole is produced at MMC, MMC is a 49. Okay, so MMC for this hole will be 49. Positional tolerance will be 0.2. So in this case, the positional tolerance will be 0.2. But whenever we will move from MMC towards LMC, okay, in the feature of, for the feature of size, we will move towards MMC, the positional tolerance will increase. Okay, when we will reach at LMC 51, the positional tolerance will become how much? It will become 51.0.2 will be added. Okay, so 2.2 will be added. Okay, so in this case, you will see that 0.2 in each case, 150, 50.1 and 51.2. Okay, so this will be the case for LMC. Sorry, we are discussing about positional tolerance. Okay, so positional tolerance will go 2.2. Okay, so this is how we get the flexibility in manufacturing, that when the part is produced at maximum material condition, because we have applied the maximum material condition modifier here in feature control frame. So after adding feature MMC, when we will move from MMC towards LMC, we got the bonus tolerance. Okay, so that's why we got the more flexibility in manufacturing. Okay, we have already discussed about the bonus tolerances. So when the hole departs from MMC towards LMC, then the positional tolerance value changes. Okay, from 0.2 to 2.2. Okay, where you have to ensure assembly, and whenever you have to reduce the scrap rate. Okay, so with the help of this, the scrap rate is also reduced, because whenever there is tighter tolerances, the part rejection will be increased. But whenever we have flexibility in the manufacturing, the scrap rate will be reduced. Okay, in all such applications, we go with the MMC modifier. You will see in the most of the automobile applications, you will find MMC modifier used, because the production which is happening is on a very large scale, and many thousands of parts are going to be assembled with multiple thousands of parts. Okay, so that's why the flexibility in the manufacturing process is a necessity. So that's why we go with the maximum material condition modifier. Okay. In the next case, you will see we use the LMC modifier. So here we have used LMC modifier. So whenever the part is produced at LMC, which is 51, the positional tolerance will be 0.2. Okay. When we will move LMC towards MMC, means from 51 towards 49, the positional tolerance become 2.2 because the it will be got added. Okay. So in this case, whenever whenever there's a requirement of a increased, I will say in this particular example, if there is a requirement of minimum wall thickness. Okay. So most of the application where we require the minimum wall thickness on a part, in such applications we use the least material condition modifier. Okay. So sometimes in aeronautical conditions and other critical precise applications, where there is material thickness is a very important aspect. Okay. In all such cases, we go with the least material condition modifier. Okay. So in this session, I have already told you three new terminologies, which is RMB, regardless of material boundary, MMB, maximum material boundary, and LMC, least material boundary. Okay. So one by one, we will be discussing about this. So first of all, regardless of material boundary, RMB is a condition where the stated tolerance limit must be met irrespective of as build datum, feature size, or location. Okay. So when a datum reference datum reference is a feature of size. So this is a condition. Whenever datum reference is a feature of size and no modifier is applied, then it is the regardless of material boundary. Okay. So in this, there is no requirement of the material boundary. Whenever this datum is a feature of size and no modifier is used, this is a default condition. So RMB is a default condition. In this case, no modifier is required. Okay. So it is no modifier is applied, and then this is condition is called the regardless of material boundary. Now, whenever maximum material boundary is a boundary that the datum feature of size will not violate. Okay. The MMB is calculated by combining the MMC size with any applicable geometric tolerance or on a datum feature of size. The MMB is always outside the material. We will know this. The MMB is always outside the material. Okay. Whenever we use the maximum material condition for the feature of size with the geometric tolerance, we can use for the datum reference, we use maximum material boundary. Okay. So MMB always used with the datum reference. Datum reference. Okay. So this is the very important thing. Now we will understand one more terminology, which is about the least material boundary. So least material boundary is a boundary that the datum feature of size will not violate. Okay. Sorry. The LMB is calculated by combining the least material condition size with any applicable geometric tolerance on the datum feature of size. The LMB is always inside the material. Okay. So least material boundary is always inside the material, and MMB is always outside the material. Okay. So we will be discussing with the 3D aspect also. Okay. So this is very important. So whenever there is whenever a datum reference is a feature of size, datum reference is a feature of size, and least material modifier is applied, then and least material condition modifier is applied. Okay. Then it is called the least material boundary. Now we will understand that how to override rule 2. We have already discussed that whenever there is no modifier used in the feature control frame. Okay. So it is a default condition, which is stated by the rule 2. But whenever we are using the MMC or LMC, maximum material condition or least material condition modifier in the feature control frame in the tolerance segment, okay, so it means that we are overriding rule 2. Okay. So it is stated there, whenever MMC and LMC modifier is applied in the tolerance segment of the feature control frame and MMB or LMB modifier is applied in the datum reference frame segment of the feature control frame, then rule 2 is overridden. Okay. So what does this means? That we are coming out from the default condition. What is the default condition? Whenever there is no modifier is used, whenever there is no modifier like maximum material condition and maximum material boundary is used in the feature control frame. So it is a default condition whenever no modifier is used. When we use the modifier, means we are coming out from the default condition and we are overriding rule 2. Okay. So whenever there is a requirement to use the maximum material condition or the least material condition with the maximum material boundary or the least material boundary, we are coming out from the overriding rule 2. Okay. So this is all about rule 2 and how we have to apply that, where we have to apply the default condition, where we have to apply the MMC modifier, and where we have to apply the least material condition modifier, LMC or LMB modifier. So now it is gotten clear that what is rule 2. Thank you everyone. We will see in the next session. Thank you.